Welcome to this video on conducting a hypothesis test for paired means with summary using RGuroo. Let's begin. A fitness coach wants to test if a new training program improves sprint speed. She measures the 100-meter dash times in seconds for 23 athletes before and after the 6-week program. Use a 5% significance level and the summary provided to determine if the new training program was effective at improving sprint time. So here is our summary. The sample mean difference, x bar sub d, is 0.5 seconds. The sample standard deviation is 1 second, and our sample size is 23. So before we go to RGuroo to compute our p-value, let us first think about what an appropriate alternative hypothesis is. So recall, for paired hypothesis testing with two means, we only have three possibilities. We can either say that the population mean difference is greater than 0, it's less than 0, or not equal to 0. But what is this mu sub d of which we speak? Well, it is the average difference of the sprint time before training minus the sprint time after training. So let's think about this. If the training program was effective, would we expect this value to be positive or negative? So you can take a minute, pause this video, and kind of think about this and formulate an answer. Well, improving sprint time, right, that is the key phrase right here. So does that mean that we want the sprint time to be longer or shorter after these people have gone through the training program? Well, improving sprint time means that they will be faster, right? In other words, their time should be shorter or should be less than the time it took them to run the 100-meter dash before they started the program. So in other words, the sprint time before the training program and after the training program, when we subtract those, it should be positive. Because again, this should be a longer time than they go through the training program. They get faster, so this time is smaller. So if you have a larger number minus a smaller number, that should give you a number that's bigger than 0. So this is our alternative hypothesis. So now let's go over to RGuroo and do this test. So when you log into RGuroo, your screen should look something like this. So we're going to come to the left-hand accordion menu, select Analytics, Analysis, Mean Inference, 1 and 2 populations. Okay? So we don't have a data set, we just have a summary. So the first thing I'm going to do is select Paired Data. Okay, and the label, I'm just going to type in before minus after. If you want to make it more verbose or a more complete explanation, you absolutely can. So remember, our sample mean was 0.5 seconds, our sample standard deviation was 1 second, and our sample size is 23. We are not given a population standard deviation. So we don't want to analyze population 1 by itself or population 2. We just want to analyze the difference between the two populations. So we select this last tab. Furthermore, we don't want a confidence interval, we want a hypothesis test, so we select this tab. And we've already talked about how our alternative hypothesis is mu sub d is greater than 0. So we're going to do a t statistic since we have a small sample size and since the population standard deviation is unknown. So doing that, we get a p-value of 0.0127048. So the question remains, is there sufficient evidence at the 5% significance level to support the claim that the new training program was effective at improving sprint time? So here's our p-value, here's our significance level. As you can see, the p-value is less than alpha, or less than the significance level, which leads us to reject the null. So we say that there is sufficient evidence to support the claim that the new training program was effective at improving sprint time at the 5% significance level. Now, normally I would end the video here and you're free to click away. However, there's one more thing I'm going to talk about, and that's very simply the difference between statistical significance and practical significance. So we know statistically that our data was significant, that we did improve training times. But is that the same as having a practical significance? So let's think about that. So the sample mean difference was half a second. We improved our sprint times for the 100-meter race by half a second. What would that look like if it was practically significant? Well, what that would mean is I would have the difference between losing the race or not placing in the race to placing in the race. And the only person who can answer whether that is a significant improvement is the people who are running in the race. In other words, they would have to look at whatever, let's say they're running at a local meet, right? They would have to look at the times that are competitive, that are going to result in placing first or second in that race. So does decreasing their speed by half a second get them into the zone of placing for that race? And if not, right, they might have to repeat it and continue the training program to continue decreasing their time, right? Or they might have to adapt a different training program that results in a more significant decrease in run time. So again, I'm not saying yes or no, this has practical significance. It's just something that you always want to think about. Because just because a hypothesis test results in us rejecting the null doesn't mean that we have developed some sort of treatment that has practical significance, or if you want to think about, in a commercial way, that it's going to result in something that I can sell or a product that people want.